name is Hyoun Park, and he is the CEO and Chief Analyst at Amalgam Insights. He's going to talk to us today about 5 quick sports analytics lessons to bring to work. So, Amalgam Insights, it's a research firm focused on helping companies cut IT costs and to transition from BI to AI. Through his career, Hyoun has focused on bridging practical gaps in mobility, data analytics, machine learning, and finance in venture capital-backed startups, enterprise IT departments, and as an independent analyst and consultant. All right, I'm going to go ahead and bring up Hyoun up here on our stage. Hello, welcome to the DATAcated Conference. Thanks for hanging out backstage there.
Sure. Hi, Kate. Pleasure to be here.
Absolutely. Pleasure to have you here. I'm going to give you the stage, and I'll share your screen whenever you need me to.
Terrific. So welcome, everybody. It's great to speak with you and great to talk to you about sports analytics today. And going back to the last presentation, I got excited about that because once upon a time, I worked at Bose, where we had both retail and manufacturing challenges as well. But today I'm here to talk to you about the sports side. And what I find exciting about sports, sure, you have all this activity and all this physical exertion that goes on. But what I really love about sports is that you have defined events, you have specific outcomes that you're trying to get to, and you have a lot of historical data that you look at. So it's great that they've created all of these sports here to create basically laboratories for us to conduct both analytic experiments and to look at what can happen from a predictive perspective and to see what happens when models go right and when models go wrong and when we can iterate on them. So once upon a time, my introduction to analytics was actually when I was in college. I learned predictive analytics as part of my chemistry background. And then after college, I used that, of course, to play fantasy baseball, using a lot of the predictive analytics capabilities that I had learned to honestly play fantasy baseball and start betting and playing in for money leagues. And that was actually how I made money once upon a time. And then I grew up and decided I needed a real job more. So let's move on to some of the lessons that I've learned from that and from and going forward. So first of all, I think it's important to find the right champion, because the right champion in looking at sports analytics or analytics in general really helps you to do things faster than your competitors. Being able to look at the data the right way and being able to have the resources necessary. You have to have the right environment to be able to work quickly. And what I mean by that is that we've all heard about Moneyball and why Moneyball matters. But Moneyball is something that happened in the 2000s. We think of that as when statistics really started. But here's the truth. The most important day in Dodgers history, the Los Angeles Dodgers, famous baseball team, April 15th, 1947. On the upper right-hand corner, you see Jackie Robinson, who played his first day in baseball in Major League Baseball that day and integrated the league. So obviously that was the most important part. But in the middle here, you see a guy named Alan Roth, guy with the papers on his desk. He was hired the same day by the Dodgers as the first statistician in baseball. And this was in 1947, good 50 plus years before the baseball analytics revolution was supposed to have happened. And the reason this happened was the guy on the left side, Branch Rickey, was the manager who decided it was important to have numbers and metrics and analysis of what happened. So all of the data that you see today, all the analytics that you see today, a lot of that comes from Alan Roth, the guy in the middle, who worked for the Dodgers for 15 years as a statistician and then worked for the TV networks after that, providing all those stats you see about, oh, this person batting against left-handers, or this person pitching against right-handers, or this person on day games, this person on night games. A lot of the stuff goes back to Alan Roth, the guy in the middle, because he found the right guy to work with back in the day. If you find the right person in your company, in your organization who cares about data or analytics, you can do things that are a complete moonshot compared to what you're doing right now. It's just a matter of finding the right visionary sometimes and being able to get decades ahead of everyone else. Second, choose or create appropriate granularity. I find that this is a big problem. I know this was a problem that I had a lot of times when I was forecasting stuff on the fantasy baseball side, trying to decide what was the correct level of event that you're trying to measure and that you're trying to analyze in your sports data. So the biggest example that I can think of is football, real football. We call it soccer here in the United States. But part of the challenge is that you have all of these analytics, everything from your heart rate, your speed. But what really happens at the end of the day in a football match? You have goals, and often you can have null ties, or you can have 1-0 gains. So it can be a real challenge to figure out which metrics are right to go with which outcomes. And I think part of the challenge with football here is that really your opportunities change on a step-by-step or second-by-second basis. And the analytics, frankly, aren't quite there yet to figure out exactly what the opportunities are, especially when you are playing team against team. And this has been a real challenge in this area, whereas with basketball, baseball, American football, we have a lot better idea of how to use the metrics to align to outcomes. So in football, what you really have to do is track that process and figure out when a player is in the right situation, or trying to figure out how quickly they're moving, how they are trying to get to the outcome, and then make those observations quickly and track that process, because often that process and figuring out the potential from each situation is more important than just measuring what leads to a goal at the end of the day, because the opportunity for a goal can be so sparse within the game process. Next of all, removing extraneous details. One of the things that we see in basketball is, if you look at the top, obviously basketball is a very fast-moving game, 5-on-5, positions always changing. One of the brilliant things that has happened over the past decade is what you see on the bottom half is basically reducing the physical presence of the players into dots, literally pixels that can be tracked on a rectangle. And that way you don't have to worry about necessarily where are people's hands, where are people's feet. What you're really focusing on here with this lower graphical representation is simply 5 pixels versus 5 pixels, their relative positions, and then where's the ball. And this doesn't give you a perfect understanding of what is happening from an analytic perspective, but what you can see is ball movement, as well as defensive and offensive positioning. And this really allows you to see how players react to each other and what the actual outcomes are based on these team versus team positions. And I find this really interesting because you start seeing shapes that occur. You start being able to understand that spatial positioning much better. And you don't have to quite worry about how quickly people are moving in real time, where frankly, it can be too hard to follow for the normal human being. I know that when I'm watching a game in basketball, I definitely enjoy watching basketball, but it goes a little too quickly for me to really be able to analyze. I'm not a coach, I'm not an expert in these, but being able to track, oh, these people are 2 or 3 feet away in a less graphically challenging situation, and by removing the data that matters less, I'm able to understand what's going on more easily. Okay, standing by tough decisions, even if they break the status quo. This is an important lesson that sports teaches. And for this, I'm going to go back to American football. So if you aren't familiar with American football, there are kind of 3 big decisions that I think of here. First of all, you get 4 chances to move 10 yards. And if you do that, you get more chances to be able to move the ball forward. Second, if you get the ball all the way to the end, you score what's called a touchdown. Third of all, after the touchdown, you get a chance to either score 1 point by kicking the ball or 2 points by running the ball in. So the funny thing is, in all 3 of these situations, coaches are traditionally very conservative, more conservative than the data states. And it's kind of funny because American football is seen as very macho sport. These 300-pound guys with slamming it into each other, and just all these people who are taking such incredible physical effort to go to do whatever it takes to move that ball. And then on the other hand, you have these coaches that make extremely traditional and conservative decisions they are very reluctant to actually try to score a touchdown. They are very reluctant to actually go for trying to get another chance to keep possession. And they end up actually making decisions that are bad for their teams because they don't follow the data and they are too focused on the negatives of what happens if we fail. So often they'll be in situations where it is 60%, 70%, 80% chance of success, where they should definitely go for it, where they should go for 2 points, go for the touchdown, go for getting another chance to move the ball forward, and they just don't do it because they don't follow the data and they are too worried about failure. But analytics can often provide a data perspective that is different from the mainstream. And it's important to at least take that data into consideration. Otherwise, you get this American football situation that happens all the time where everybody on the field is trying as hard as they can. And then some manager makes a gut decision, not a data decision, that ends up being bad for everybody as a whole. What you can do is at least provide the data that says your gut is not the right way to go. Finally, when the data gets better, change your approach. So now I'm going to come back to baseball. So baseball, we have 100 years of data. Ball can be a fastball, ball can be a curve ball can be a slider. There are all these different ways to actually throw the baseball. But what you can see is that, and for 100 years, that's all we really knew, that's how a pitcher threw. About 10 years ago in baseball, we started getting to the point where high-speed cameras could actually see how fast a ball spins. So all these numbers you're seeing right here on the screen really start showing how quickly a ball spins on a per minute basis. So average fastball by a right-hander spins 2,275 times per minute, and about 40 times a second, give or take. And we can tell how much spin a ball has, and often more spin will be better, less spin will be worse. It kind of goes back and forth, but we have this new data that says how good a pitch can be. And it's now we incorporate that data into understanding how a pitcher works. So it's not just about a pitcher throws this fast or a pitcher throws a fastball, but now we have this additional data that we can add to the models. Likewise, don't be afraid to add new data, and you might have to fundamentally change your analytic process as you add that new data in. These are changes that happen. That's because we have a better understanding of what is happening. It's important to keep that in mind as you are working with your data. So those are the 5 quick sports analytics lessons you can bring to your work. Find the right champion, choose appropriate granularity, remove extraneous details, stand by tough decisions, and change your approach when the data gets better. And with that, thanks for taking these quick hits. Thanks for coming to this talk.
Awesome. And thank you so much, Hyoun. Wow. I love your passion for the field. And I feel like this is probably the first time I've understood sports. So thank you for the quick explanations for each of those. You had a lot of comments coming in about real football. So I thought that was pretty funny. We are short on time, but we do have time for one question. And we'll take one from Anor. His question is, he says, we have enormous historical data about the game statistics, but how do you model a player's personality traits or characteristics? Do you use video game logic, scoring every trait, or I'm not sure, have you heard of this before?
It's funny. There are teams that actually use psychological profiling when they are picking players, and they're trying to figure out how people do, especially in high stress situations, because that's what really matters for most from purely from a sports perspective. When everything is extremely stressful, how do players react? And they have metrics to measure everything from how quickly do you see something and how quickly can you react to changes, to just physiological things like your sweat, do you run faster, your adrenaline. Like they have metrics for incredible amounts of stuff. And obviously with Internet of Things, you're able to track things as well. So there's a lot going on there as well.
Awesome. Thank you so much for explaining that. And Hyoun, thank you again for being DATAcated with us today at the DATAcated Conference.
My pleasure.
All right. Thank you.